Poor Uranus. It's got rather boring clouds, truth be told. So there wasn't a lot to see with the cameras.
Passing close to the planet, Voyager's sensors reveal why Uranus is so featureless. Temperatures here are the coldest of any world in the solar system. There's simply not enough heat to drive the storms seen on Jupiter and Saturn. Uranus is an entirely new class of planet.
We knew long ago from telescopic observations the rings were there at Uranus. We didn't know their configuration or their shape.
Voyager begins to explore the ring system and spots something curious in the shadows. Two moons, Cordelia on the inner edge of the brightest ring, and Ophelia on the outer edge, help to organize the system.
Particles within the rings can be moved inwards or outwards as these tiny objects called shepherd moons, whose gravitational force can shape and sculpt the rings themselves. The rings, rather than looking like that when you look through a telescope, they're actually orbiting up and over the top of the planet. The whole thing is tipped like a spinning top.
This bizarre orientation hints at an unusual past. Since the beginning, everything in the solar system has been circling in the same direction. It begins with a vast cloud of material that orbits the young sun, and spin on their axes in the same counterclockwise direction as that primordial cloud. Except for Venus and Uranus, which spin in the opposite direction. But Uranus is even stranger, because the entire planet is on its side.
This was a really strange system. So why is Uranus so tipped on its side?
If a roughly Earth-sized object smashed into Uranus late in its formation history, then that would have had the proper amount of momentum to basically knock it on its side.
And the collision may also help to explain another of Uranus's mysteries: why the planet is so cold.
That impact presumably relinquished all of that internal energy that the planet had when it first formed, and has left it as a relatively dead and sluggish world.
Much is learned during this brief encounter. But Voyager's strangest discoveries are yet to come. What powers weather is very different depending on where you find yourself in the solar system.
The Earth's atmosphere and the weather on Earth is driven largely by one thing, and that's the sun. And the sun pours its energy down through the atmosphere, and it hits the surface, and the surface of the Earth then warms up.
With Earth, you've got all the energy coming in from the sun, heating up the surface, creating thermals that then drive the atmospheric flows that we see. Somewhere like Saturn doesn't have a surface to be heated up. So when you compare the weather systems on these giant planets to those that we have on Earth, you have to sort of tear up the rule book a little bit.
The sun is the great controller of Earth's atmosphere. But in the outer reaches of the solar system where Saturn lives, sunlight is 100 times weaker. It means some other heat source must be driving Saturn's incredible weather. As Cassini studied the cloud tops of Saturn, it was able to infer a huge amount about the truly strange world that must lie beneath, and the energy source that helps power this planet.
We had a whole variety of scientific goals at Saturn, and one of the main ones was to understand the meteorology of the Saturn atmosphere and what energizes the winds that we see on it and so on. And
so everyone was observing it, and they realized two things. One is that it had just passed very close to Jupiter and probably had gotten pulled apart by Jupiter's tides. And the other was that it was going to crash into Jupiter 2 years later.
The discovery that a comet was about to hit Jupiter was a huge surprise and very...
We knew that the impacts were going to occur on the night side and that Galileo was going to be able to see them.
On July 16th, Galileo sees the first fragments of the comet enter Jupiter's southern hemisphere.
At 60 kilometers per second, the fragments really heated the atmosphere, red hot, almost to the temperatures of the sun.
And the pieces hit the planet one after the other.
Pieces of comet Shoemaker-Levy 9 strike Jupiter over the course of 6 days.
They looked like big flashes on Jupiter. The pictures of the impact were fantastic.
These tiny points of light, captured from 240 million kilometers away, are the only time a comet strike has ever been witnessed.